Hello students, let us study the concept of dielectrics. Dielectrics are insulators which do not have free charges for conduction of electricity. Right? Free charges are always responsible for the conduction of electricity and it doesn't have. And it's a insulator, kind of insulator, and it is of two types. One is polar, another one is non-polar. Right, and polar is having a dipole moment but non-polar having no dipole moment. Okay, so now let us study what is polar and non-polar. Let us take a polar example, that is H2O. So in H2O, you know this one, H2 is plus and O is minus. So this one is O, oxygen, this is H, okay, and this is H, right? O is minus, so let us place the minus charge here, the center of minus charge here, okay. And for 2H2, this is H and this is H, okay. Where should be the center of mass? You know, if a system is like this, plus and plus, where should be the center of charge? Here. If the center of charge is here for O, oxygen, where should be the hydrogen and hydrogen center of charge? Somewhere at here. And they are maintaining a finite distance between them, that is 12. Suppose. Because of that, these are called as dipole. Okay? And they are capable of making dipole. Now let us take, this is the example of polar. Now let us take what is non-polar. In non-polar, let us take the example CO2. This is C, this is O, this is O. Okay? This is carbon atom, this is oxygen atom, this is oxygen atom, CO2, right? And in CO2, you know C is plus and these are minus and minus. For this plus, where is the center of charge? Here. For these two minus, where should be the center of charge? Again for the same case. If these are minus and minus, where should be the center of charge? Here. So where should be the center of charge? At the same place, because they are in the same line. Right? If the center of charge is here for the carbon, the center of charge for the oxygen will also be here. Okay, and they are not maintaining any finite distance. Who? Plus and minus are not maintaining any finite distance. So that's why these are called non-polar. Okay. So if I will take polar atoms and place it in between the electric fields, they will start conducting, right? So these are the parallel plates. This is plus charged, this is minus charged, okay, and let us place the polar atoms here. Okay, so this plus will take the minus of this one, okay, and because of that, what it will become? Plus, right? And this plus will now attract the minus of this atom, right? And this will become plus, and this plus will attract the minus of this one. Like this process will continue. Previously the electric field was like this. This was the original electric field. Let us take it E naught. Now the plus has reached here, right? So there is a reverse current, or you can say there is a reverse electric field. Let us name it as E, due to this dielectrics present in between, right? So polar dielectric molecules, when exposed to electric field, the positive and negative charges are forced to develop distance between them and they convert to a dipole having certain moment, right? These are notes you have to write. And E naught is the original electric field. Which one? This one, E naught, right? EI is the induced electric field. This one is EI, induced due to dipole, right? So to alignment, so what is your E net? Net electric field is E naught, higher one, minus of EI, induced, right? See the derivation. Let E naught is the electric field applied, decreased by EI, induced electric field. E is the net electric field, right? So my E naught is directly proportional to E, and it is decreased by a factor, right? Which one? E naught is decreased by a factor, but what is the factor? K. So E naught equal to K into E. So what is my K? K equal to E naught by E, or you can write E naught equal to K into E, where K is dielectric constant. So let us take the formula of C. C equal to Q by V, and we know due to surface charge density, sigma equal to what formula? Q upon A, charge upon unit area. So what is Q? Sigma into A. Sigma into A whole divided by V is what? V is minus E into dr. We have already derived, right? So instead of minus, let us take the whole magnitude value E into d, distance d. Instead of dr, I am taking d. Okay. Parallel plate with dielectric constant K, E will develop as E naught by K. Let us check E here. So what is E answer? E equal to E naught by K, right? So C dash equal to sigma into A whole divided by, place the value E naught by K. Where I am placing? Here I am placing, right? E naught by K into D. So K will go up, K into sigma into A by E naught into D. So K into sigma into A, and what is the electric field E naught formula for a sheet? We have already derived this one during your parallel plate capacitor. And for a sheet, what is the electric field inside? Sigma by epsilon naught, right, into D. Okay, this is because of E naught equal to sigma by epsilon naught, right, into D. So this is equal to K into epsilon naught into A by D, right? This is the answer. Okay, capacitance C dash, final one. But one doubt is there in your mind, why we will use this dielectric? Okay, now see, in K is what? Dielectric constant. So if I will increase my K, what will increase? My capacitance will increase. If I will increase my dielectric constant K, my capacitance will increase, right? Previously the formula of capacitance was what? In your parallel plate, only epsilon naught A by D, and here one K is extra multiplied, right? So more space I can create. Capacitance means what? Space. So more space I can create in a capacitor by using dielectric constant K or dielectric material. Thank you.